Activity 2, Calculating Slope. This is a part of Unit 4, Analytical Geometry. Solve and get involved. The steepness of a road, a hill, a mountain, or ski slopes are often encountered throughout our daily lives. In fact, if you don't mind running up some inclines and through some rough terrain, the cross-country team at the school may be looking for you. The distance you are expected to run is between 5 and 10 kilometers. Even if you are not the fastest runner, it's often the one who has lots of endurance that can finish the race. This leads us to our next math topic. What about the steepness of a line? Why might we be interested in that? What does the steepness of a line represent? Over the next two activities, we will investigate. First, let's consider the problem of calculating the slope of a line. Here we see a line segment placed upon a Cartesian plane from points A to B. It has a rise and a run. The rise is how many units it goes up vertically, and the run is how many units it goes across horizontally. The slope is defined as the ratio of rise or vertical change of a line to the run or horizontal change of a line. That's what we define as the slope. It doesn't necessarily have to be from endpoint to endpoint, though this is often the easiest way. The calculation for slope is equal to rise over run. Here we see a drawing of the edge of a house. Consider the roof of the house below. There is a rise and a run indicated on the roof. The rise of one side of the roof is 3 meters and the run is 5 meters. That would indicate that the slope is rise over run. The slope m of the roof is given by m rise over run, or 3 over 5. Calculating slopes in roof construction is very important when you're considering construction codes within certain areas. Calculate the slope of each of the following graphed lines. Here we have a graphed line with 2 points. We have a rise and a run. And since our points fall naturally upon easily indicated spots along the axes, we can actually calculate this using our slope equal to rise over run formula. We know that the change in the vertical distance was from 50 to 10. That was the first or vertical line. And the change in the horizontal distance was from 10 to 1. The rise was 40, the run was 9. We've calculated 40 over 9. So the slope of this line segment is 40 over 9. This next line segment also has a rise and a run. We use our slope calculation. Slope is equal to rise over run. The rise is a difference in y values. The maximum y value is 5. The minimum y value is 1. The run is a difference in x values. The maximum x value is 4. The minimum x value is 0. It's also important to note that the 5 and 4 matches up with the point 4, 5, that is the top of the line. And the 1 and 0 matches up with the point that is the bottom of the line. We take the y coordinate from the first point first and the x coordinate from the first point first. And we calculate our slope. When you get to a fraction like this that can be reduced, you should. The slope is 1. Go ahead and try this yourself. Plot the points A, -5, 1, and B, -2, 4. Then when you're finished, go ahead and find the slope of the line. Once you're done, come back to see if your solution is the same as ours.